All right, in this lecture I'll be covering firms in perfect competition. We'll start by reviewing the assumptions of a competitive market. Here are the assumptions laid out. In a perfectly competitive market, we've got a market with many buyers and sellers. So many buyers and sellers, in fact, that everyone is a price taker. The product being bought and sold in the market is a homogeneous good. What do I mean by that? I mean that firms are selling identical products. Okay, so if I'm a seller and you're a seller in this market, there's no difference between the good that I'm selling and the good that you're selling. And finally, we're going to assume that firms can freely exit, they can enter or exit the market. Okay, so there's no barriers to entry or exit. No barriers. I mean, there are more assumptions than this. I guess if we really wanted to be thorough, we could include them as well. I guess an obvious, or one that should be obvious, an assumption that should be obvious here is that firms, that firms are profit maximizing. And we're going to assume that there is perfect mobility. I guess the best way that I can explain this is for us to picture a market where maybe we've got a very, very large farmer's market, and all of our sellers have booths that they've set up in the market, and we can essentially assume that everyone, buyers and sellers, are all in the same place. That if I see a seller at one booth that's charging 5 cents more or anything more than the going market rate, I can just move over and buy from a seller that's charging a cheaper price. And I can see all of those prices, and I have what's called perfect knowledge. Perfect knowledge of the good that's being sold and also of prices. I know what everybody else is charging. We could also make clear that there is symmetric information in this market. Buyers and sellers have exactly the same information set about the good in question. And let me think, are we missing anything here? That there are no transaction costs. So there's nothing, no additional fees that I have to pay as a buyer or a seller as I trade this product. And let's see. I think that just about covers it. One last one. That there are no externalities. We've already covered what happens in a market with externalities, either positive or negative. So we'll assume that we don't have any of those in this market. Okay, quite a lot of assumptions. But these assumptions are necessary in order to see this particular result that emerges. Okay. So with all of our assumptions down, let's do a little bit of review. So as a firm tries to maximize its profit, we'll start with this formula here. Now again, we're talking about economic profit. And if you don't recall the difference between an economic profit and an accounting profit, you should go back and check out the previous week's lectures that I posted. Okay, now here we know that economic profit includes both implicit costs and explicit costs in the formula. So we'll start with a very basic formula, total revenue minus total cost. And their total cost, just a, little side note here. Total cost includes both explicit costs and implicit costs. Implicit costs there being things like the owner's foregone wages, the implicit rental rate of capital, and the opportunity cost of interest earned on financial capital as well. All right. Now, total revenue, once again, is calculated as price times quantity. Here, firms are unable to engage in price discrimination. Price discrimination, now there are different forms of price discrimination. You could think of it for now as just a firm charging different prices to different consumers. Maybe that's like a movie theater that charges different prices to students than they would to non-students, or perhaps a firm that charges a lower per unit price to customers that buy in bulk, or an airline that charges different prices based on when you buy your ticket, right? Months out in advance or, the day before. We're going to assume that since this good is homogeneous, there aren't different goods that the firm is selling in this market, and also we're going to assume that they can only charge one price. So this is a single price situation. Okay. Now, a few other points that I want to make here, important for our conversations. Average revenue will equal total revenue divided by quantity, and marginal revenue will equal the change in total revenue over the change in quantity. If you're familiar with calculus, the marginal revenue is the first derivative of total revenue with respect to quantity. Okay. Now, an interesting result for our purposes here is that for a firm in perfect competition, average revenue equals marginal revenue, and this equals the price that the firm is charging for this good. Now, this will become clear through a little example. Now, maybe I'll think about this really quickly here. Let's see. Suppose that this is our firm. This is, I'll do two graphs here actually. Okay. In the first graph, we have supply and demand. I'm going to consider an agricultural market. Let's say this is the market for wheat. Okay. And we're going to assume that the wheat that everyone is buying and selling in this market is identical, right? Homogeneous goods. Now, with all of the assumptions we made, we know that this market will be perfectly efficient. And there will be some equilibrium price in the market. And think about this for a moment with all of the assumptions that we made before, right? With the fact that everyone's selling the same good, everyone is a price taker, and there are so many buyers and sellers that no one buyer, by holding out for a better price, has any impact on the market price. And so no seller is successful in increasing their price or charging a price that's higher than the market rate. Because if we did that, I mean, just imagine we had two Coke machines side by side, and this Coke machine is selling a bottle of Coke for 75 cents, and this Coke machine is selling the same, or not exactly the same, but the same product. What I mean is it's not exactly the exact same Coke bottle, but it's, for all intents and purposes, you have no preference between buying the Coke bottle from machine 1 or machine 2, and they're charging a price of 50 cents. Well, who in their right mind is going to buy from Coke machine 2 when right next to it is a Coke machine that's selling the same exact Coke for 25 cents less? That's what I mean. So if we've got firms, so many firms in this market, everybody's selling the exact same good, buyers don't care who they get their bushel of wheat from. They just want to pay the cheapest price. And so we're assuming things like, the quality is the same no matter who you buy it from. Now, these are simplifying assumptions, obviously, but in this type of market, we have to think, let's see. Let's suppose I have, this graph over here displays the supply and demand curves. So the market for Farmer Brown's wheat. Okay, and we'll put Farmer Brown's demand function on this graph. The demand for Farmer Brown's wheat will be perfectly elastic. Now, let's not yet focus on why Farmer Brown can't lower his price. Okay. For now, let's just think about why he can't raise his price. Now, if Farmer Brown tries to raise his price, obviously every buyer that could buy from him will buy from someone else now, because everyone else is charging the market rate of E sub P, the equilibrium price. Okay, so he tries to go above that. Demand for his wheat will fall to 0. Now, at the market price, the demand for his wheat is theoretically infinite, right? Because we've got so many buyers, so long as Farmer Brown is producing some quantity of wheat, there will be the demand to meet that wheat. Now, obviously, Farmer Brown won't be able to supply an infinite amount of wheat because he's got some cost structures, which we'll talk about here in just a second. Okay. All right, so let's talk about Farmer Brown's cost structures. From the last lecture, we learned about average fixed cost. We learned about average variable cost, and we learned about average total cost, where average fixed cost is fixed cost divided by quantity. Average variable cost is variable cost divided by quantity. And average total cost is total cost divided by quantity. In addition, average total cost equals average fixed cost plus average variable cost. All right, we got to this point last time by showing that total cost is equal to fixed cost plus variable cost. And it's an important point that in the short run, all of these implicit costs, these opportunity costs for the firm, are fixed costs, and fixed costs in the short run are sunk costs. So we're really kind of more concerned with variable cost. Now, I do want to include average fixed cost. So let's see here. If we've got fixed cost divided by quantity, then as quantity is increasing, fixed cost is a constant. So that means that this constant, as we divide it by ever increasing quantities, average fixed cost is going to decrease and get closer and closer to zero at larger and larger quantities. Average variable cost for a typical firm may decrease at first and then continue to increase at larger and larger quantities. Okay. And let's see here. Just give me 1 second. Just have to check on something. Okay. Now, average total cost will, at very small quantities, be very close to average fixed cost, which I forgot to label. Average fixed cost. And as we increase, average total cost starts to look like this U shape, and then at larger and larger quantities starts to get closer and closer to average variable cost, because at very large quantities, average fixed cost represents a very, very small percentage of average total cost. Now the marginal cost curve, right, which is total revenue divided by quantity, starts out down here and continues to increase and intersects the average total cost curve at its minimum point. And last class we learned that this point here is the firm's efficient scale. So this quantity here, efficient scale. Let's see. Okay. Now, if this represents Farmer Brown's cost curves, I also want to make one point clear here, which is that this is the price that Farmer Brown is charging, right? Because he's pretty much forced to take the equilibrium price as his own price. This demand function is also the marginal revenue function, and it's also the average revenue function. But I care more about this marginal revenue part. Recall from earlier classes that economic profit is maximized where marginal revenue equals marginal cost. So that's exactly at this point. Here's my marginal cost curve. Here's my marginal revenue curve. And this is the intersection point, which happens to also be at the minimum average total cost curve. Minimum point of the average total cost curve. Okay. Now, what is Farmer Brown's economic profit at this point? So let's review one other formula here, which is that economic profit can be rewritten. I'll start with the formula that I had previously up here. Now, total revenue can be rewritten as price times quantity, and total cost can be rewritten as average total cost times quantity. Where did I get this from? Recall that I said that average total cost is equal to total cost divided by quantity. If I multiply both sides by Q, these cancel out, and I'm left with total cost equals Q times ATC. All right. So let me further rewrite this as Q. I'm pulling the Q out, and in the parentheses I have price minus average total cost. All right. Now, a quick note. If price equals average total cost, then what is economic profit? Economic profit is equal to 0, which I also explained in last week's lectures, but another little piece of review here. We could call this a normal profit for the firm. Now, some students might be confused by this. They might say, well, if profit is 0, then the firm can't continue to operate. But you need to remember this is economic profit, not accounting profit. I agree with you. If accounting profit is 0, or let's say less than or equal to 0, yeah, the firm is going to shut down. That's the shutdown point. However, in this case, economic profit also includes those implicit costs. We're thinking about costs as opportunity costs. What this means is that the firm can do no better by exiting the industry. They'll stay in the industry. They'll continue to operate in this market. If price is greater than average total cost for the firm, then the economic profit is greater than 0. Now, in this case, we'll refer to this as supernormal profit. And finally, if price is less than average total cost, then economic profit is less than 0. We could call this a negative economic profit or an economic loss. Okay. So going back to our previous example, we can see here that the price is equal to average total cost at this efficient scale quantity. So what does that mean? This means that if I see this graph, I know that Farmer Brown's economic profit must be 0. Is Farmer Brown going to stay in this industry, continue to produce and sell in this market? Yes. Yes, he will. Now, remember, there are many firms in this market, and recall that firms can freely enter or exit. There are no barriers to entry. Think about this as money on the ground, right? If firms are earning a supernormal profit, meaning there's economic profits, positive economic profits earned by existing firms in the market, then this is like saying there's money on the ground. Other firms will enter in to try to grab that money. So if this is the case, we'll think about this as scenario 1, scenario 2, scenario 3. If we're in scenario 2 here, existing firms are experiencing supernormal profits, then new firms will enter. There's nothing to stop them from entering. If we're in scenario 3 and firms are earning a negative economic profit, keep in mind they could still be earning a positive accounting profit. These firms, we'll call them existing firms, will leave. They will exit the market. Okay. Now, what happens when firms enter into a market? When firms enter into a market, recall this is our overall market. I've got demand and supply. One of the determinants of supply is number of sellers. So if new firms enter into the market, then this is going to shift the supply curve to the right, which in turn will lower the equilibrium price and raise the equilibrium quantity. So this is what happens when new firms enter. Okay. When existing firms leave, let's draw another market. Let's say existing firms exit the market. Then the reverse happens. So we've got supply and demand. And in this case, firms exit. The supply curve shifts to the left, and this is our original equilibrium quantity, our original equilibrium price. The equilibrium quantity decreases, and the equilibrium price increases. Okay. So these are the key results that I want you to think about. Now let's go back to a situation where suppose that for whatever reason, maybe demand originally, maybe demand shifts to the left, okay? And this causes the equilibrium price to decrease. All right, so we've got some existing firm here in the market with many firms that have the same cost structure, right? Because we could think that, at least think of this in this way, that there are an infinite number of suppliers, right? Infinite number of firms in the market. So obviously, all of the firms that are in the market have, there's a distribution of cost structures, and let's suppose this is Farmer Smith. Okay, Farmer Smith, we'll say market for Farmer Smith's wheat. And let's suppose that now we've got this new equilibrium price, which equals the price that Farmer Smith is now forced to charge. And let's say this is Farmer Smith's marginal cost curve. This is also Farmer Smith's marginal revenue curve. But the new price is below Farmer Smith's average total cost curve. Okay. If this is a situation, then we can tell that the price is less than average total cost. And this is the quantity that Farmer Smith will choose to produce. This is his profit maximizing quantity. Give me 1 second. My iPad is about to die. Want to make sure that this stays charged. Okay. All right, so let's go through this quickly. I continue up along this quantity line, and this is Farmer Brown's per unit cost of producing this level of output. And the result is that this box here, this rectangle, this represents Farmer Brown's economic loss. Or Farmer Smith's economic loss. Now, Farmer Smith will choose to exit this market. And when Farmer Smith does this, the equilibrium price in the market will go up a little bit, right, for those firms that are still in the market. Now let's look at another example. And we'll say this is Farmer Jones. This is the market for Farmer Jones wheat. And meanwhile, so this is a different scenario. Say this is the equilibrium price, and this is Farmer Jones's marginal revenue function, and okay, this is Farmer Jones's marginal cost function, and this is Farmer Jones' average total cost function. Okay. Now Farmer Jones will choose to produce where marginal cost equals marginal revenue. It's profit maximizing level of output. However, his average total cost at this level of output is less than the price, which means that Farmer Jones is experiencing a positive economic profit or a supernormal profit. And this rectangle represents the positive economic profit. Now, what happens in this scenario is that other firms will enter into the market. As they do, that drives the equilibrium price down. And they'll continue to jump in so long as producers like Farmer Jones and others are still making positive economic profits, right? Existing firms in the market. But as this equilibrium price falls, eventually, this is going to put us at a new price. This is the equilibrium price, and this is a new marginal revenue function. Farmer Jones will produce less output, and this will also put Farmer Jones at a production level equal to his efficient scale. Okay. So, this outcome where Farmer Jones is experiencing a positive economic profit, and this example where Farmer Smith was experiencing a negative economic profit. These are both examples of short-run outcomes. This is a short-run equilibrium. This is also a short-run equilibrium. Now this outcome, the first one we looked at, this is a long-run equilibrium. Think of it like a steady state, if you will. Now, as supply shifts to the right or shifts to the left, or as demand shifts to the right or shifts to the left, right, the market will equilibrate. What do I mean? We'll go to a new equilibrium, and that will raise the price or lower the price. And as the price goes up or it goes down, this will cause either economic losses or or positive economic profits for existing firms in the market. Now, if this new price causes economic losses, these firms will exit, and the firms that stay in the market will experience some, I guess the price will then go up a little bit. But as so long as firms are experiencing a positive economic profit, like Farmer Jones, other firms will continue to enter, and eventually we can think about this long-run outcome as a sort of, when the dust settles, firms in the long run will earn a economic profit of 0 in a perfectly competitive market. Okay. Now, since I'm doing this lecture, pre-recording this lecture, and I'm sitting here staring at my iPad and not looking out at a room full of students, I can imagine that you might have some questions for me, maybe some things you want me to clarify. If you do, please email me, or please post something on the course site so that I can see your questions and respond to them. Hopefully, I've explained these things in a way that makes sense, but I cannot see any confused faces right now in the crowd because there is no crowd. Let me think just for a moment. If there's anything that I've missed while explaining, okay. All right, I think we're all good here, at least as far as I can tell by looking at my notes. So again, if you have any questions, just let me know, and I'll be happy to answer any that come up. Okay, see you in the next lecture.